Yeah, so wait, these guys will give me a name. I wonder if they'll get
Alrighty, we can get started. I believe the two teaching fellows that will be missing tonight are Reggie and Mary. That should be all that I think won't be here tonight. If someone else ends up not being here, let me know so I can get a little piece of paper around for attendance. Before we break off and talk about the classes that you all just learned about over the last 2 days on your own, go over the glossary of terms first. So, well, before I jump into this, I want to cover two administrative things. One is the number of classes left until the end of Unit 1. It's not seem loud enough. Is everyone able to hear me all right? All right, let me know if you can't, and I'll try to fix it. So what is left for the class? All fits on a page now. So we'll have tonight, crypto assignment, which you'll get a good portion of tonight to work on if you haven't had a chance to get it done yet. We'll meet Monday, and then Thursday of next week, if you've looked at the class schedule, is largely a make sure you've completed everything you need to, and you can work on it next Thursday if you want to. I'll cover some other fun topics, or if other people want to cover them. That's what next Thursday we'll do. That will be the last time we meet in person before we come back again on January 9th, that Monday, which I'll mention again on that Thursday, but I want to give everyone an idea. Next week is our last week before we break for holiday and winter time, but there will still be 2 assignments due the Sunday after our last day together here. The other thing that I want to mention is that if there's inclement weather that we don't think enough people will be able to make it to class, I will cancel it. I will cancel class, and likely what that means is it will end up pushing class another day forward. That goes for the whole winter time, so next week as well as January and February and March, when it's likely to have snow that could cause problems getting here. If I have not, so my goal is going to be to send a message on Slack as well as on Vocarium, not Vocarium, the one that starts with P, Piazza. I'll post a message on Piazza and on Slack if the class is closed. Ideally, it will be by 1 p.m. the day of class, so everyone can make sure if you normally make plans for some form of night care for your kids or anything, hopefully letting you know by 1 p.m. the day of will make undoing those if you don't need to easier. If I don't call class off, but the roads are still not great where you live, where you're coming in, the class is not worth driving through dangerous conditions to get here. So please don't, if you deem the roads unsafe for yourself. So those are the administrative. Any questions around what's left for class or how class canceling will work? If anyone has a better communication mechanism than Piazza and Slack, let me know. Those are the only 2
that I know of where I can know I'm contacting everyone. All right, want to make sure, so things to talk about in the groups before we come back. Can I show you all about classes? Want to cover the sort of words around the classes, because I think this is one of the areas where it starts to get confusing when writing programs. So first thing is you have a class, which is basically, I mean, it is an object, but a class is just another container for information. An attribute is a part of a class. Constructor is that init method, essentially. That gets called whenever you construct your class. Instance is, after you've made a class, instantiate is the act of making your instance. Method are functions defined on a class. So if you have a dog class, you might have a method called speak. You'll see in a little bit. That would be a method. Methods are associated to that object. Same way that whenever we had the turtles, we had the move forward, move left, right. Those methods on the turtle object. Object is the base data type in Python for everything. So we've been using them the whole time for anything that we have written has been an object. Object-oriented programming, or often as you will see it on the internet, OOP, is a style of programming where you break off a lot of logical chunks into the entities that you would represent them as in the real world. An object-oriented language are languages that specifically provide features for doing object-oriented programming. There are languages that don't actually allow it. For instance, there's one called Haskell. If you're interested in a different type of development, it's what's called a functional language. Python is a procedural and object-oriented language, which I mentioned in the reading. There are other types of languages as well if you want to play around with them. But talking about the classes, what I wanted to get everyone to do. Also, in your group, if you're still having trouble with crypto, talk about it for the next 10 to 15 minutes. I'll wander around and I'll explicitly try to go to Mary and Reggie's group to help out if I can. Break. Instead working.
I don't know. It's the third one.
Using
Yeah, so for which way is it?
Which I have no question so should I be doing this differently? Should I put it in?
Well, right now, this is so.
Yes. And then, and other
Depending on what you, depending on what you.
that here, which then feeds down into. So now I'm going here.
So as opposed to this is good. That's what I see. That part is fine. So, it is, I mean, that part is fine. So. It's just this way to keep it. Yeah, but I don't know. Well, probably.
Exactly. I should be right now, but what do I do? I still didn't get that. I didn't, yeah. I tried, like, you act like you're hitting something. Yeah, but I still didn't get there. I mean, yeah, I thought it was just good. I was recording. Yes.
And it's this second rotate here. So I think you're gonna have to rotate here and figure out rotations.
Oh, yeah, and then you can get that from
So I'm using it.
yeah. It'll be like this.
Oh, yeah. So, more like. No. I'm not sure.
That's the rotation.
The rotation balance, so rotation balance, I'm getting a team. And then I'm putting this together, and that's my rotation. That's I could just say the library.
But it always be a period, right?
It should. It should. I gotta go back and look. What I've done last night
Oh, we do a lot of content.
Yeah.
Don't you love that? Yeah. Just one.
So I need to put something else.
Yeah.
What I'm thinking is if that, because if it's a character that is not, it's ignoring ours, so we should follow it. We should follow.
Yeah.
0.6.
Great.
So this would perform it without doing logic.
You don't need to do, you don't need to check for that. That would be a problem. The issue is that we're, let's say the key. First of all, again, just keep throwing up. So that's what the model is.
There's another statement. Because like, there's one of them. That's don't do it.
Right now, it's just a car. It's just a. It's actually.
I was like, I don't
And I,
but because like I had all these things.
but I
And I was just like, I don't want to say. I hardly ever, I've always hated about things. Yeah.
So ROT is a number.
Okay, so you watched this. I don't want to watch it.
The Charlie are getting
Take the original letter. Okay.
like Don Cullen. So that's what you would do for rotation. Or before you call rotate chairs.
So. Do I not?
Oh, there.
Yes, that's correct. Just pick a number.
It's for cheap.
Yeah. So inside of. Yeah. That's where you want to break up. All those take character has to be built in character and the number of places to rotate. It doesn't even know what the key is. It's just takes character and gives you the character. So everything related to figuring out the rotation has to occur outside of so inside of the script, every time you're going to character your message, it has to figure out what the rotation should be by position. Next character. Yeah, you're gonna call, well, you're gonna call it. So that'll give you. The rotation. So listen, if you go to the skill exercise. You go down to the bottom. Skeleton. Skeleton. So, okay, so we have 13. Not like, because ROT is. But I think that's actually the whole key.
So. Yeah. So. I wonder.
Yep. Yeah, this makes sense. This is
Yeah, it's.
pretty much what you need to do is you just have to hit that little bit more code to handle moving up there. So it's the same name. So ROT here, ROT here is the value by which you're going to take. So probably.
So they need to change, yeah.
You're on the right track.
I don't know if that would really.
All right, I'm gonna break everyone's concentration and we're just gonna start talking about classes. But programming classes, not like this class. So we reviewed the terms to start off with, and I am gonna cover some of the problems people were having with crypto and getting the assignment submitted, but I'm gonna do that just after this, so it can be fresh in your mind right before you go in and try out finishing up the crypto assignment. So Python classes, the main thing about them, one, they're not just for Python, and two, it's a different programming paradigm than what we've been doing to date. So the big difference between what we've been doing now and classes is classes give you a way to logically group both your information, your data, and what you want to do with that information. So as an example here, the first class that I wanted to make, since everyone already definitely read the reading beforehand, I went with already adding a method, a bonus method on the class besides init. Sort of as an example, the simplest class you can create. That's not where I wanted that. Oh well. So you could create a class called simple. You have a simple instance. Then you can print your simple instance. That is the most basic class you can create. And it sort of mentioned this, I think, last week in the reading. You can use the word pass in Python, basically say, I want this whole block of code to just kind of do nothing. So in Python, what happens here is I created a class that just has a name simple. And now I have an instance of that class. But because I've defined nothing about it, it's sort of mostly useless. The default implementation Python gives you for your class, if you try to go and just print it out, is this really easy to read thing that says name.simple, or depending on where you're running it from, will say simple object at, and then the actual memory location on the computer, which you don't care about. So what I normally do as soon as I create a class is I override the string method that is the default. And so then when you print it out, you get a nice little easier way to read it. If you wanted to make it a little bit, so they're actually different. All right. So then you use that correctly. So then what happens here is you see the name, and then if you remember in Python, if you call ID on any object, it gives you its unique identifier in the entire system. So sort of the simplest way to identify an object so you know you don't have the same one. The reason for that is I could go and create simple instance 2. At simple, I go ahead and print out simple instance 2. Should have done that to begin with. And if we notice, so they both print simple because they're supposed to, but because they're different objects in memory, these two numbers on the end are different. So when you go to create a class, so representation, a way that when you print it out, you can tell what it is, it's a good idea to include as much information as you can to make it as unique as possible, so that if you go and print out 100 of them, they all look the same. This is sort of the most simple class you could create. Notice that I didn't override the init method, because you don't need to unless you're actually going to set something up more there that you would need to. So here in my dog class, you can do the same thing where you write documentation. So we're writing all of our functions and having doc underneath. Same thing holds true for classes. If you go and document the class just underneath with your triple quotes, it makes it easier for anyone else that is reading your code to then know what your class is. And then if someone else is using tools to sort of auto-read all of the code, it'll pull in that information, and we'll get to know that your dog class represents a dog, and it can make a sound. So what I do by default for these dogs, and this is what I mentioned, the init function is what gets called whenever you go and instantiate a class, which the first instantiation that I did was here. When I called simple the first time, I instantiated the class a second time, which is why I have 2 simple instances. So down here, when I go and instantiate dog, and I get my dog, what I've done is I have set the sound that the dog makes to bark, and I put it into a category called mammal. That's where dogs fit. That's a redundant comment. Shouldn't have those in your code. The comment below it, though, is helpful because it tells you the sound the dog makes. So what happens here, the two different ways that I've called these, I'm calling a method and an attribute. The method in this case is speak, because it is a function that is defined within the class dog. And the attribute, category, is defined within the init method. So anywhere that you do self dot some variable equals a value inside of your class, you are assigning that attribute a value. So right here, when I go and run this, I call the speak method, then we see that the dog barks, and then I call the category attribute, and that is where we get to see what a dog is a mammal. So my next couple examples get to be more complex than this, so I wanted to show you a more realistic ways to use classes than what the examples in the book did, because in Python it is incredibly rare that you would ever create a method like this. So it would be very rare for you to create what's called a getter method. Where you would say dog.get category. The reason is, as you notice just above, you can access it by attribute. So it is unnecessary in Python to create what is called a getter method, where you're basically just saying get and then the attribute name, because Python does not require it. So in almost all Python code you will see, you won't see methods for getting a value like that. And if you do, so like I said, I'm gonna reiterate the same examples that I worked through on Monday around the dictionaries for the rooms and people cleaning the house. However, I find it much easier to understand what's going on in working through the house and finding how much work people have done by using classes, and it also makes it easier to get more interesting results. So for this first one, what I wanted to show is, so I'm going to repeat these classes, but I want to show the base structure of each one so you don't have to go over it each time. So just sort of like the dog above, we have a room class, we initialize it, a room has a size, and a room has a name. We can get the name. So I created a get name class on the room that will do a bit of work to make it so you can get a better looking version of the name of the room. So you'll notice below, I'm using that dictionary still that I used on Monday to have a base data set to go and create all my classes from. But each one of these names isn't very easy or nice to read. So within this get name, what I'm doing is using a method on the string class called split that will split it into an array by every underscore. Then I'm calling another string method called capitalize for every word in that array that I just created. And what that does is it goes and creates an array where every word in that is capitalized. So in the instance where I go and call living room, it will go and capitalize it on. So if I went and made this, for instance, be playroom, it goes and prints out playroom, so you can see where it's capitalizing it. Unless you're in the back of the room and then you can't see it at all because I didn't scroll down. The reason that works is in the under string or under store method. I'm using the name and the size, returning that as a string on its own, so that you can see the name of the room and how big it is every time you print it out. So the sort of the representation of what a room will be. And as usual, if anything is confusing or unclear, feel free to ask questions or wave. Tell me to slow down. I haven't done it a lot yet, but for strings, it's nice. It's often nice to use that dot format method so that someone can see sort of how the string should generally look. And then in the format, you don't actually set the values that are going to be in there. So you can do it by having them named, how they are there, how I named them name and size. And then I go and set their values in here. Format is just a method on the string class that I'm using there, so that it prints out and it looks nice. Now, as of, if you are overriding the strings, and then you go and make a list of your objects and print them, you're going to get something you may not expect as your result. So now if you notice, this looks like my simple object did to start with, where it printed out and it didn't have anything to use there. The reason that this, when you print it out inside of another object, is because if that print only really goes one level deep when it goes to print an object. So when you put multiple together, there's actually a different built-in method. So this is a built-in method on all classes called under string. There's another one that you can override that's not as necessary to override because you won't see it as often, called repr. R-E-P-R with double underscores on both sides. I'm purposely not overriding it because I, in general, don't recommend it, because if your string version and your repr version are different, that's actually good. String is usually what you want humans to read. The repr is the object's representation, so that's generally more of how the computer sees it. So when you go to print something out like this list, and it looks weird because you put it inside another collection, don't worry about that. So you'll see below what I've done is, instead of printing it out in that way, so if I have a list of rooms, I just say for room in my list of rooms, and I print the room out. It's called one room. I'll print the room out. So that is my recommendation if you're trying to print a list or collection of things, to just iterate over it and print it out. No. As memory, before we go forward, room class, it has a get name, and it has a size and a name like it did on the dictionary before. So as we saw it Monday, it was just a dictionary with keys that represented the rooms and values that represented the size. Something that's nice about classes is if you want to go and add color, or if you wanted to add dimensions such as width and length and height, you can add all of those onto your room class. Whereas in a dictionary, you'd have to go and create a bunch of other dictionaries to hold all of that data, or have a much more complex list here where you're assuming a certain order to your list for all that information. So classes make it a lot easier to organize that information together if you have something about a room you want to keep. So all I'm doing here is I'm creating now all those room objects based on the dictionary that we had before. So the same sort of pretty print before that showed attic, its size. Now what you can see when I go and make them be room objects instead of a dictionary, they look a little nicer whenever they get printed out. And you can see sort of a uniform what size each one is. Next up is a person class. So for the people, for each person, they have an age, a name, and what rooms they are supposed to be cleaning. So just like we could for regular functions, for methods, you can also use parameters that have default values. And in this case, if the rooms have no values, I set it to an empty list to indicate that there is a list of no rooms. Otherwise, I go and set the rooms to whatever the person creating that, whatever the caller creating a person decided. And then there are two methods on this person class. One is a method to add a room, and the other one is a method to remove a room for that person that they're in charge of cleaning. So much like we did the other day, I set up kid 1, kid 2, adult 1, adult 2, but this time they have names. Billy, Sandy, Sam, and Chris. So now they're no longer anonymous. And one of the reasons that I always choose to use none as a default parameter, unless it is an integer or a string, usually, is you can run into problems in Python when you use something like a list there or a dictionary. And the book slightly hinted at this because those are both mutable objects. Which means what can happen is each time you go in to find a person, if you pass in a different list and on that last person you don't pass in a list, because this is assignment right here, anywhere that you do an equal sign in Python, that is saying that rooms is assigned the value of none. None is not a mutable object, so you can't change it. It's immutable, unchangeable, just like the strings were or the integers were. But if I were to allow that to be a list, so if I were to change this and just say self.rooms equals rooms, what can happen is in the future, so if I come down here, just to demonstrate, yes, so right now they all have an empty list, that's fine. Now if I come in here, it's a different off of the classes, it's actually going to be fine. The state you can end up in, I don't have room here. No, it's going to be too much work. What can end up happening is that one list that I gave with one item, is it ends up getting repeated depending on how your code is running, to where Sam and Chris would also have a list of one, even though I didn't pass it to them. Which is why the safe option for your functions, whether they are attached to a class or not, always check if it's none. If it is none, then you know that you have a default you want to give it. Else, give it whatever the user passed in. which in this case, they don't have any rooms. So the next thing I'm going to do, same thing that I did on Monday. I'm going to add all of the rooms to people. And as this example builds, I'm actually going to add more methods to people. So I wrote all those little side functions, sort of just generically got averages and such. I'm going to put those all on the person object so that we can know how each person did. So same room class I had before, same person class. So in this case, I have Chip. I'm assigning Chip all these rooms. And I'm printing out each room. So this is the example of the rooms as they exist on chip.rooms. That's still a list of rooms, which means you're going to get that strange printout that just says it's the computer's representation of the room class. Whereas instead, if you loop over each one and print it out, you get the human's representation of that. So same as before, I went example of just assigning a person to having a bunch of rooms. Same setup, rooms, the number of rooms, the person. Now what I've added here so that we don't have to keep doing that loop every time is a print rooms function on the person. So now what it's going to do if we call that, it's going to go over each one and automatically print those rooms out for us. So now what I'm doing is I'm iterating over the rooms, each one, creating a new room and adding that room to Jennifer. And then what happens here is we print out Jennifer's rooms. You can see them all, but I went and created a method on there now so that if you want to know what rooms are there, human readable, you can just call that method and you don't have to worry about iterating over the list of rooms every time. Because the class itself knows how it wants you to see the rooms. So this example will sort of include everything from Monday. Same person class, setting it up, add room, remove room. I'm adding a method on here called amount cleaned, which will be the amount of area whomever gets assigned the chore cleaned. Then we have the rooms with size, room class again. Now I'm recreating those same 4 people. Set the people up, set the rooms up, and that same while loop that I had on Monday, where I go and I copy all the rooms that exist, go over each room, and if you remember or not, there was a lot of extra code in this while loop because there were not classes on Monday. So if we look at Monday's example, for the while loop, where I went and added them. So right through here, I'm having to do this if check, add them to rooms if they're there, because I have to go and keep my own dictionary of those people. So this is Monday, it's just using only dictionaries because we didn't have objects yet. I'm having to go and manage the state or the representation of a dictionary in order to know who's going to clean what room. Whereas once we have objects, all I have to do is say add this room to this person, and it handles it completely because I put all of that logic on my person class. So now it's as simple as give me a person, give me a room, I'll assign that room to the person, and then remove that room from my list of possible choices. So we go from needing 7 lines of code to doing something to only needing 4. So almost cutting it in half by using a class to encapsulate the logic. off in one spot. So then what happens here? Same thing that we saw the other day. On Monday, we'll see that each one cleaned some arbitrary amount because just randomly choosing rooms. So if we do it a second time, the amount each person cleans changes. Well, see in this case, Chris didn't clean anything. So my classes are set up the same. This last example that I have here wanted to show sort of an advantage. One of the other advantages of having a class is something we couldn't do very easily on Monday was figure out the average amount each person themselves cleaned. So the average size of each room they cleaned would require a lot more effort on our part with the dictionaries to sort of keep going over and seeing the average that they did. Whereas now what we can do is we can just say, all right, we have our rooms, go over them, and return the amount that the person cleaned, so that method from before, the amount they cleaned, and then just divide it by the number of rooms. And I'm using a built-in function called round to have it only go to 2 decimal places. That's largely because there were a number of scenarios when I was testing this where it went out to like 40 decimal places and made it really hard to read. And then I'm returning by default 0.0. The reason for that is because here in this division that happens in this round, that returns a float. And if I were to return just 0 here, this method would return a float in some cases and an integer in other cases. So in general, if you have a function or a method and you're going to be returning some number type, you should strive to always return the same type so that your caller can always expect similar results. Because what could become strange is if someone calling this function always depends on getting a float, so they always expect it to be formatted something like 100.02, so they could expect to do some currency formatting, for instance. If you don't return a float by default on the last one, then they end up just getting 0. And depending on how they've written their code, they may not handle getting something without any of the decimals there. So I'm choosing to return a float in both cases, even though it may seem redundant to do 0.0 so that anyone calling this function always gets the same type. And I make sure that the number of rooms is greater than 0 so that I don't get an integer division by 0 error thrown. Same setup that we had before with the rooms together, set them up that same, only need the 4 lines instead of the 7 previously. And then it is kind of nice here because now we can see that on average what each person's cleaning between the rooms that each one cleans. So for instance, between Sam and Bill, they end up cleaning just slightly different sized rooms, even though their overall square footage is not as close. But they're both cleaning 3 rooms. But because it's random, it'll change every time it goes through. Oh, is that a little closer? So are there any questions on classes before I go and cover the argv bits for reading command line tools? I was kind of mosey. I'll assume it's crystal clear. All right, so this I wanted to cover an example here of this is very basic program that if ran will tell you what arguments are passed to it, and it will also tell you if no arguments are passed. So a function that might be helpful for others is this function here that goes and imports argv, which is provided by Python, that whenever this file is invoked, it will go and check what arguments have been passed to the current running program. The reason that I go and check -1 is every Python program that executes is guaranteed to have at least one argument, and that argument is the file name. By using -1, what I can verify, I won't ever hit an index out of range error on my arguments because I'm guaranteed to have at least one. Now, if that argument happens to be equal to this under file, there's a very strong chance that the program has been passed no arguments. Now, you could pass your file name multiple times, and then likely what you would want here to verify, we can just add it. The length of argv is greater than 1. So if both those conditions are true, actually that is less than or equal to 1. Both of those conditions are true, then file passed in only has one argument passed to it, the Python call, which is the name of the file. It has nothing else passed in. The reason that's helpful is whenever you go to write the sort of command line interpreter there, when you're running your file, say for the Caesar cipher, and you're wanting to pass text in or the number in, you can know if they passed any arguments at all versus they passed 1 or 2 arguments. Makes it easy to have a bailout immediately to go and say, oh, they didn't give anything. I'm just going to print out the help text. So in this case, what I'm doing is I'm printing out that they didn't pass anything. So the way this function here works is I'm just printing out whatever arguments they passed so you can see them. And then I wanted to demonstrate the reason that I use -1, so you can always see the last argument passed in, which is what I'm depending on up above. And then I'm also wanting to print out the type, which will always be a string whenever you pass in arguments to your program. So here, I go and pass my Python. I can call Python 3, whichever one. So I do Python read arguments. What happens is it prints out in that list the arguments that were passed in. Says that the last argument was that program. The reason for that is Python is saying, so Python is the command you're running, and then you are telling it the first argument, which is the name of your file. That is why in that list there, the first argument is the name of your file, because the argv says what all of the arguments passed to the Python command were. So in general, if you're calling your own file, you don't usually care what that very first one was. You just care that you got other arguments. So in this case, the last argument is the file name. It's of type string like it should be, so I printed out that no arguments were passed in. Now if I were to go and print something like hello world and 2, the quotes are necessary, otherwise it will end up being read as more arguments being passed. So in this case, I end up passing 3 arguments. Last one with the value of the string 2, as you can see, is the class 2. So if you were curious, if I were to just type hello world, I end up with 4 arguments passed instead of just 3. And that's because the way that the terminal reads arguments is it uses the white space to delimit each item as an argument in the terminal. So anyone have any questions on this concept of running with main for each one of your programs? All right, I don't think there are any questions. Tonight, there is no studio, I believe. I believe there's no studio. I'll verify for all of us. So everyone, if you have no questions, work on crypto. And if you have any, as questions arise about crypto, I may come back up, but feel free to work on crypto. That's the goal. The reason for the extra time tonight is so that everyone can make sure you get all of your questions you have about the crypto assignment answered in person. So if you're running into any big problems, you're not sitting at home Sunday at 10 p.m. banging on your computer, wishing it would upload the files or wishing they would execute how you want them to. All right, that is all we have for tonight from a new information standpoint. All right, work on crypto. Yes, so ArgV, the way that ArgV is, so anything in the sys package is in Python is created so that you can interact with the operating system, no matter if it's a Mac operating system or Windows. And what ArgV does is it tells you what goes past the Python. So if you're running a program through Python or through something, one of the fancier IDEs, I don't use a fancy one. If you were to use ArgV, whenever you use your files, you can print that out and see what all it's trying to do. Whenever all ArgV does is hold everything that's passed through Python. Whenever that's current session. So even programs that go and run, say like a web server, or like if they're running for somebody's Python database, they're all launched essentially by something that goes Python, some file, or some order of argument. So one area where ArgV is used a lot is in web frameworks. A lot So for instance, if you want to have a project here, if you want to see an example, work. Ignore these commands. This is just so it works. So in here, there's this manage.py file. So this is using sys. So Django is a web framework that makes it easy to make websites, that backed by database, backed by various different things. This is the entry file for it to run your entire website. So what happens here is it has that same, if it's main, go and execute this code. This is, so OS and sys are both things that will be, Python provides across operating systems, so they'll just work with any of them. This environment variable is a way so that outside the program you can set something and then it knows, okay, I'm going to use this file called mysite.settings. Read that for settings. Now what happens here is I'm passing sys.argv to this other program. And what this ends up doing is I can now do this /manage and I can pass help. And then that's the command. So the command is help. And then it goes and has, so it tells me what I passed in, but it tells me what I can do next. So they've written their program such that if you pass them the arguments that were given to the file, yeah, it prints this, these are all the things I can do. Yeah, so argv, right here, all that it got was manage and help. That's the sort of example where there are programs that actually use it, and it's largely used for so something I can do here is I can say manage, and then that gives me a Python interactive shell here. And the reason that's a little bit different is in this framework. So in Python, you normally have to do a lot of stuff to get, so if you notice whenever you use this user cipher, if you use it in the same directory, you could import from that file. But if you have files in a bunch of different places on your computer, it makes it a lot harder to, you have to sort of figure out how you're going to get all those imported in one spot. This little helper command that exists in this framework goes and opens up a Python shell interpreter for you, and it goes and pulls in all of the files in your project so you can sort of debug then each one of your files more easily. So I have a don't remember what all is in here. There we go. So if I run that command, I can say from blog and so I have a models. So I have a class in there called post inside a module called models. And it goes and does all of the work, pulling it all together so I can run it. But that's why you would, long answer to the question is the reason that you would use argv a lot of the times. So if someone's providing you some command line tool, it makes it a lot easier for them to know what you want to do. So argv is generally only used for sort of these command line tools. So as a writer, you have to, there are actually other classes in Python. When I say classes, I mean classes that allow you a lot easier way to set up little command line tools, and they're using one within that execute from command line function. Yeah, so the thing that automatically outputs the help in that, they set it up such that you can make a class and you tell it basically, okay, it asks for help and print this out. So that's not where I'd like to go. People can get their issue up to creating a class that is, if they have the word help, it has different words. It makes it a lot easier to set it up than having to go and manually parse all the arguments yourself. There are two options. Older versions of Python use hard parse, and newer versions of Python use hot parse. Hot parse makes it a lot easier to fill in which I mainly, so I've written a few for myself. So I do have a lot of repetitive types. So I need some type it. Yeah. And one of the reasons was in the cipher, mentioned specifically calling it as it's causing a lot of problems. Submit it to a parent, running it locally, get it running locally, and then submit it to a parent. It's going and trying to get arguments in areas it shouldn't be. And it's making assumptions about how long it does, which is why I showed that function.
Oh, I could have shown a better example here. So if I just type Python and I do from sys import, and then I just print.
There were no arguments passed in because all I called was Python.
I just had a two-second question. That was great. That was really relevant to what you asked about. Do you have any clue as far as unit to Django? The only reason I'm asking is last week we was talking about Django, and then I noticed that the admin was specifically on Flask. So I thought, oh, okay, so I have one.
So I don't believe Unit 2, I don't believe will actually be doing a lot of Python.
They're in the syllabus, they're going to even Catherine mentioned explicitly during whatever
Right.
it was, that there was going to be just a little bit of backend stuff in Python.
Right.
And then questions about just like straight Python code.
Right. So I think what we're going to do initially, and this is where I'll actually know for sure, I believe next week. They did this class starting in June of last year in St. Louis. They're restructuring Unit 2 and 3, which is why I have terrible details on both of them, because I just get little bits. So the for sure things that we will cover is HTML, JavaScript, CSS, we're getting a web page to show. The backend, from what I'm seeing so far, looks like it's going to be we just write straight Python to serve for the little bit to practice doing front end. If you are interested in Django, this Django.
Yeah, no, I was like, I came up like, yeah, I'm glad to sit in and say that.
There's a Django Girls tutorial. It's a really good tutorial for trying out Django and seeing web. It's actually the best tutorial I've seen for the Django web framework, which is interesting because Django itself has documentation with the tutorial on it. As good as this tutorial. So this tutorial covers everything from your command line setup to your editor, as well as
Great. Thanks.
Stuff for the last two classes, because I missed last two and I checked, and it looks like it's not active. Go up to the canvas and I can see.
So if I come up here, so December 5.
No, that one's there. It's the actual class. Oh, you put it in the other one. Okay.
Did I not put? I'll just add it to both.
Because I was just confused because I went to like the actual class, not the prep, and I didn't see it.
No, that is correct. I should have put it in the
Because I
class.
saw it.
I clicked the wrong
for
one.
9, but I didn't see it for 10 and 11. 10 and 11.
Right, I put it in the wrong one.
Okay. Well, I just want to see because I missed those two classes. It sometimes helps me remember to go through your examples again. So.
Right. I failed to do that. Ooh, and it had it still.
Yeah.
There we go. And the same is true for the other one. I put it in the pre instead of the.
Okay.
I will fix it now.
Okay. Thank you.
You're welcome.
Yeah, because I know. So when it passes. Which time? Pretty much. I can see it right coming. I just probably change up his name and say. When I get down to better. We told us not quite like yeah. I will. Sure. Alright, so Is the returning is shares are running. I used to sit up. I mean, I typed in all this, but it was a combination
Oh, yeah, oh, yeah. Yeah. Stuff like I don't see myself doing it. I don't see it. Yeah. I'll tell you what I actually have to Yeah.
So I had
reading back to chapter 3. Yeah, reading back to right.
Yeah. Makes sense.
okay, so why is the
That's right. I'm just looking at this.
Yes, sir.
We did this.
Would it be?
Other than like two really crazy. Yes, it's see you can like so absolutely. Literally say, okay, first time it's not changing. Second time it's changing. So our team is here. You're going to maintain right from the beginning. So you should create another index variable with key positive. I LTR here. Yeah, that's right. Relevant position. I know because you already have function. So the LTR square braces. ROT square braces LTR. Maybe. Okay, so that's the multi-ring one. So that all of it. And then, okay, so you have the LTR. One. There's a problem with that. You have to write it here. What's going to happen is that's one. Yeah. You have a whole world. So what a lot of still on the plus one. LCR. Like what happened? Take all that out. LTR. We'll just make sure that you stop right with that. Right with that. There's still more of this to come. Just because I do. Space that you don't want to mark it into return space. So you grab all those things. Yeah. Inside of the or you can say, yeah, let's take care of it. Let's take care of it. I'll stick with that. Else, well, else, letter equals letter plus. Like, yeah. Look, yeah. So, for chart in the region, chart okay. So what's happening here is you're going to check each item. So you go through the process. Then and it's one. Well, I'll skip the part. Spacers. You're good, right? This is all fine. This is your done. There might be something else. Got this. You can forward the chart. Right here. I don't know. Check. Oh. Yeah. Yeah. So you just, you throw the link on your screen. Yeah. Well, this code is mine.
One person left.
Try the message that's in your Oh, there it is, yeah.
So it's not supposed to. It just happens like that.
Here, like James looking. So we.
So, yeah.
Oh, that's happening.
But it's X-ray.
So, press enter. And you can see, press items in alpha and where else have you. Oh, I know what the issue is. I don't know why it's. Otherwise. Oh, yeah.
Yeah, that's correct. Start that.
What's it? Yeah.
Yeah, but it's
I had done this. Oh, yeah. It can work. Magic can work. This is nothing. It's like 10 miles. Yeah, it's Sunday. This is like I think yeah, well, yeah, he's cool. He's cool. But it's just funny how all of a sudden and he told me he's like, oh, sorry. No, I just thought I knew. He told me something else, yeah, I know. You should get a job. Yeah, you should. All
Right now, you have right now, what we're doing. Good. Oh, yeah. Yeah. Oh, yeah. So right here. So now what?
Make sure you're online on Sunday night at 11:45. Alright? Yeah. Watch there.
All you can go and say.
Yeah. I think what you would need here. Oh, yeah. That way your cipher. Oh. Yeah, shard, I mean, you can use shard as
Yeah.
yes, right, but, yeah, well, I have that, no, so like, oh, because you already.
So I don't.
Oh, yeah.
Yeah.
So. So, all right.
But now I'm.
Right, so now I'm in charge. Yeah. Yeah. Over there. Yeah, I'm pretty good. Yeah. You saw that work? To rotate that. You want to So whereas right now, I'll try to do I think it was but actually, see if you like people put the plus chart. Adding message.
This is the function that just reads.
Oh, it's the character. Right, so you have this line. So the maximum is one. So you have what you need. The three steps. So the three steps. You have the first one here. The index. Based upon the index of I'm sure.
Yeah, yes.
Did you? Like download that Flex, or you gonna like have a review or? Just gonna talk. So now you have your rotation. Now you no problem. Everyone. Now you're getting. Right.
Okay. So
2.
But it was the last one, so it's, yeah. Oh, because it's.
I don't think it should. Yeah, so it's slightly. So what that means is that this rotation value. Slightly wrong. So this is 42. Because you're rotating. Here, that where so how that vision is but then determining what that would be. I think
I understand much better than. So it feels to me like, oh.
Right, so remember that priming.
But so it would indicate that this has to be something like.
So that line. So here, you're adding. You're adding.
Oh, mine.
Oh, okay.
Mine, I think. Do you have a ring?
Yes.
Okay, that's okay. Thanks for checking on it. Sure, you too. I didn't get the minute. Yeah, your statement told me. That's very nice. So, yeah, okay, so. Yes, it's returning tax. It's returning tax and I gave it tax. So it's, that's the. Thank you.
But I'm pretty sure that's accessible.
Yeah, it's doing everything we want to do all private. So I just need to sit there and look at it for a while. Some of the refactoring stuff makes sense to me as I was looking at it, and some of it doesn't, so I'm just sort of afraid I'm gonna be there at midnight.
Oh, the refactor of moving.
Yeah, because, you know, I've gotten 4 out of 5 cards written now, and I just lost. So. Let's see. You have the KC holiday party next week, that's right.
What day of the week is that?
Wednesday night. It is Wednesday, 17th.
Day of Key?
15th. Whatever this coming Wednesday night is. Okay, send in the link to the event, make it free since no one's